Bundling occurs when multiple MC cables are placed in a confined space such as the rib of a concrete deck and are not tied together. To calculate the ampacity of bundled MC cables, follow these steps. Firstly, determine the circuit voltage. In this case, the power is 208 volts 3-phase. Secondly, identify the cable sizes and types, which are 6-4, 6-3, 12-2, 12-3, 12-4, and 8-2 MC. Thirdly, find the ampacity of each cable size. Refer to Table 310.16 in the National Electrical Code, NEC, for the ampacity of each cable size. Fourthly, calculate the total conductor area. Multiply the number of cables by the cross-sectional area of each conductor within the cable. For example, for 6-4 MC cable, the cross-sectional area is 0.25 square inches per conductor, so the total conductor area would be 0.25 times 4, which equals 1 square inch. Fifthly, determine the adjustment factor. Table 310.16 also provides adjustment factors for bundled cables. Find the adjustment factor corresponding to the number of cables bundled. Sixthly, calculate the adjusted ampacity. Multiply the total conductor area by the circuit voltage and then multiply by the adjustment factor. As an example, suppose you have 3 6-4 MC cables and one 12-2 MC cable bundled in a rib. Step 1. Circuit voltage equals 208 volts. Step 2. Cable sizes equal 6-4, 3 cables, and 12-2, 1 cable. Step 3. Ampacity of 6-4 MC equals 75 amps. Step 4. Total conductor area equals 3 times 1 plus 1 times 0.21 equals 3.21 square inches. Step 5. Adjustment factor for 3 cables equals 0.84. Step 6. Adjusted ampacity equals 3.21 times 208 times 0.84, which equals 579.1 amps. In conclusion, the adjusted ampacity of the bundled MC cables in the rib is 579.1 amps. This value should be used to ensure that the cables are not overloaded.